Meetup today, Rockset database. So I'm stop
Yeah.
sharing and your turn.
Okay, I will start sharing. All right. Checking if everyone can see my screen.
Yeah, just let us know if you would like to have the standard Q&A session. So we wait until end of your presentation, or there will be some break somewhere in the middle, and we can. You can answer the question. Of course, me and Philip will moderate. So if there will be any question on chat, so we can read it. So it's up to you. Just let us know when is the good moment to read the.
Sure. Yeah, I'm gonna go over this. I'm still seeing your screen. I'm trying to see my
Yep,
screen. All right. Okay. We're still
because
good. You guys can see.
there
Okay,
is magic
cool.
button to ignore or stop presenting. So I already stopped. So
So I resume presenting. Okay, this should be good. All right, everyone. Welcome to our tech talk. We're going to go over how Rockset can ingest, index, and serve data from any source in real time. And when we say any source, we really mean like a data lake, a data warehouse, a database like a transactional database, and even a data stream like Kafka and Kinesis. So I'm Nadine. I'm the Senior Developer Advocate here at Rockset, and I primarily work on developer content and community. My background is in engineering. I tend to focus on anything within the IoT space or database space. And prior to Rockset, I actually worked at Bose, like the headphone Bose, and I worked on the watchOS SDK to integrate with the headphones, as well as I worked with partners on mobile integration for iOS. So Jack, do you want to go ahead and give a little quick intro to yourself?
Yeah, sure. Thanks very much, Nadine. Hi, everyone. I'm Jack Ferrari. I'm responsible at Rockset for building our presence in EMEA, and I meet lots of companies around EMEA to understand their data initiatives and work out whether we can solve any of their complex data stack challenges. Prior to Rockset, I was in the software engineering space, in the kind of CI/CD space, but now excited to be at Rockset and excited to tell you more about what we do today.
Cool. So for today's agenda, we're going to talk about what real-time analytics and data applications are. And then from there, we're going to deep dive into Rockset's architecture to explain how it's able to ingest, index, and serve data from any source. After the tech talk, we'll dedicate 10 minutes or so for a Q&A. And then really good, that's really awesome. We're going to do a hands-on workshop where we'll build a movie recommendation from a data set stored in S3. So it'll be a public data set. So as you're doing this, if you want to go ahead and create like a Rockset, free trial Rockset account throughout this, that would be fine. Otherwise, we'll go ahead and get started. And if you have questions throughout the presentation, feel free to just drop them into the chat, and then we'll get to them when there's time or at the end of the session. All right. So Rockset is a real-time analytics platform built for the cloud that was founded by a team who has experience building databases and scaling systems. So Venkat is one of the founders. He's a CEO. He was the engineering director for the Facebook infrastructure team that managed online data services for over like 1.5 billion users. And these systems during his tenure scaled 1,000 times, serving 5 billion queries per second at single-digit millisecond latency, and has 5 nines of reliability. Prior to Facebook, Venkat worked on tools to make Oracle database easier to manage. The other founder is Dhruva. He's like super famous. He's Rockset CTO and was the engineer. He was the engineer on the database team at Facebook, where he was the founding engineer for RocksDB. I don't know if you guys are familiar with like open source RocksDB data store, but prior to Yahoo, he was one of the founding engineers of the Hadoop distributed file system, and he was also a contributor to the open source Apache HBase project. To date, Rockset and growing, Rockset has just under 6,000 users, and on average per monthly, as of right now, we have about 220 million queries that are running per month. So we're definitely growing, and it's a really exciting time to be at Rockset. So Real-time analytics is a very big buzzword. And what does it mean and how is it defined? And I'll take a moment to stop here. When I say real-time analytics, what comes to some of your guys' minds? Feel free to like interject and unmute yourself. I'm curious to see when someone says real-time analytics, what are some things that comes to mind when you think about it? Philippe or anyone else that's on the call. Don't be shy. Or you can type it into the chat too. I don't see anything in the chat. But I'll go ahead. So real-time analytics is all about using data as soon as it's produced to answer questions, make predictions, and understanding relationships and automate processes. So the core requirements for real-time analytics are to have access to fresh data and fast queries. So these are essentially two measures for latency when you think of real-time analytics. There's data latency and then there's query latency. So let's break this down a little bit. Data latency, which is this little pink circle that you see over here, is a measure of time from when data is generated to when it is queryable. So real-time analytics seeks to reduce the time span from when an event occurs, like a transaction, a user action on a website, or even a login attempt. So whenever there's an action of happening on the application, the time that it's sent to the database to make it available query, that's the data latency. And for analytics, you want to have a data latency for within a few seconds. The other measure is query latency, and essentially the time it takes for query results to return. So real-time analytics in application should be sub-second latency, making for a very interactive experience and also a very seamless user experience. And that's what we are trying to aim for when we think about real-time analytics. And you can see query latency on the purple circle right here. Okay, so the first two bullets, we talk about fast analytical queries, and then on fresh data, which is query latency and data latency, respectively. Besides that, you'll want to be able to ingest and index semi-structured data, regardless if the data shape changes. This means no schema definition should be required up front. And when you think about when you're dealing with like event streams, you're gonna have sometimes fields that are null, fields that are in type, and maybe even a string type, and it might continuously change. And if the data shape is changing and you're writing an ETL pipeline or something like this, you'll have to update the pipeline or update the schema. And it's a very operational like burden type of thing to do, because that's just the nature of dealing with these types of streams. It's a possibility that will happen. And so you want to be able to query, semi-structured data like JSON, Avro, Parquet seamlessly without really worrying about what the data shape is. The second thing that you'll want to think about is scale. So you'll want your real-time analytical database to scale as your business grows. And this means handling high concurrency and volume. And you should be able to adjust compute and storage as needed. And we'll go into a little bit later on for the reasons why that's kind of important. Okay, so applications where you'll need to act on fresh data kind of fall into two categories. There's user-facing analytics and there's operational analytics. So a lot of times you'll see companies or even people saying, okay, data application this, data application that, but what is a data application? So at Rockset, we kind of break it up to user-facing apps and operational analytics, or operational analytics type of applications. So user-facing analytics examples like real-time personalization engines. I don't know, Instagram and Facebook are kind of like really nailing this at the moment. I even today, like I got caught up and I was looking at some things for my friends, and all of a sudden I got these recommendations for these apartments that are coming up, and their algorithm is changing. But if you notice, like if you click on something or you view something for some sort of amount of time, all of a sudden the next time you scroll, you have all these recommendations of ads that are popping up, or suggestions of news articles or content that's based on what is of interest to you on what you're clicking on and interacting with between Facebook and Instagram. And I think Instagram and Facebook are kind of nailing this personalization type of experience. The other, other user-facing analytics are example like gaming leaderboards. I'm not sure if you guys are familiar with Peloton, but it's really popular here in the US. And like, if you have the hardware, you can see where you're at in your workouts and how you're doing compared to others. And that's another example of user-facing analytics. Now, for operational analytics, you can think of like fraud detection. You know, if someone's committing fraud, you want to be able to catch that instantly and internally prevent that from happening. Or maybe you want to capture like if something is trending and things like that. So that's an example of operational analytics. So what type of applications are, our Rockset customers building? So Jack's going to cover 2 real customer stories who are building either user-facing analytics or operational analytics. So Jack, I'll hand it over to you.
Great, thanks, Nadine. So following on from what Nadine said there, she touched upon personalization, and Facebook and Instagram are doing a great job of this. And I want to touch upon some customer stories of customers that have really benefited from Rockset's real-time analytics platform. So the first one I want to speak about is Ritual, and that links into the personalization piece as we're helping them with their recommendations engine. For those of you who don't know who Ritual are, they're an online retailer in the US that sells vitamins. They started by selling vitamins targeted to women, and then they expanded their product offering to men's and children's vitamins. And their goal when we met with them was to increase vitamin bundle sales at checkout. And they needed a real-time analytics platform to push personalized recommendations in seconds to effectively drive their revenue growth. This was not possible in their existing data stack because they were having to transform data in Snowflake and run batch analytics, which was taking minutes. And this was not meeting their sub-second query latency requirements. So how did Ritual achieve their goal that they set out to achieve? The solution was to integrate Rockset with their existing data stack. And you can see on the screen here how they've done that. The data team now builds models in Snowflake that gets dropped into S3. Rockset's built-in S3 connector instantly picks up the new data as soon as it lands in S3. We're then automatically indexing the data in 3 ways to help them achieve faster, cheaper, and more flexible queries. The team at Ritual particularly benefited from our Query Lambda capability, which Nadine's going to talk a little bit about today, which gave them the ability to turn any SQL query into a REST endpoint and make it consumable by their end application. The outcome of the project that we ran with Ritual on their recommendations engine enabled them to achieve the personalization they were looking for, and it effectively helped them drive revenue growth. So there's a real life customer example of how we've helped with personalization and recommendations engines. And we'll move on to a second customer story in a completely different space. They're called Command Alkon, and they work in the supply chain and logistics space. If you're not aware of who Command Alkon are, they're responsible for 80% of all concrete deliveries in the US. And when it comes to delivering concrete, real-time analytics is actually mission critical for them, because otherwise the consistency of the concrete can be impacted. The challenge that Command Alkon had was they were not able to run complex analytical queries in DynamoDB. And they were not able to meet their ever-changing business requirements with their existing data stack. The solution for Command Alkon was integrating Rockset with DynamoDB. Rockset has an out-of-the-box connector that ingests data from Dynamo with very low latency and enables teams to run complex SQL queries in milliseconds. The team chose Rockset due to a number of reasons, and you can see them bullet pointed here. So firstly, they really liked our query flexibility and our schemaless ingest capabilities. Our schemaless ingest capability is completely unique to Rockset, and we'll show you that later. Secondly, they really liked the simplicity of the configuration and setup. And in terms of total cost of ownership, it's very, very low with Rockset because we have built-in connectors that are managed for you, and we're fully SaaS, so there's no need to manage your own infrastructure. And thirdly, and finally, they were able to accelerate development time due to our full SQL capabilities. So there's some kind of high-level overview of how we've actually brought real-time analytics to customers and really impacted their business. Thanks, Nadine. I'll pass back to you.
Sounds good. All right. So far we've covered what real-time analytics means and challenges customers are solving. But how does Rockset provide seconds in data latency and milliseconds in query latency to power real-time analytical applications or data applications like we defined earlier? So we're going to dive into Rockset, and we're actually going to like double click into the Rockset architecture a little bit to see how it does this. So Rockset is a cloud-native real-time analytics platform for serving fast queries and fresh data from databases, lakes, and data streams. And we kind of already broke down what fresh data is, which is data latency. We kind of broke down what query latency is. And so let's go ahead and talk about the technical differentiators with Rockset. So when we think of serverless real-time analytics, we think of a couple of things at a high level. One, you're able to query your data within milliseconds of it being available. So basically on the freshest data, which is the data latency. So even if the data is like terabytes of nested semi-structured data, performance shouldn't be impacted. And here the focus is having very low latency queries on massive data sets as soon as the data enters Rockset. The second thing you want to consider is query flexibility, and this is something that Jack hinted with Command Alcon, where you can write different types of queries without worrying about creating primary or secondary indexes, denormalizing the data set, and not working with other alternatives to like a SQL join. So if you want to join from different sources, you know, that might be complicated in other data systems, and you might have to jump some hoops in order to do that. So you should be empowered to write any SQL queries without worrying about what the data shape looks like, or if you have to pre-plan for your queries and so on. And finally, there's the operational overhead with creating and maintaining shards, servers nodes, and so on. And those things should really be a thing of the past. So using a serverless architecture takes away from having you to manually optimize, or your team dedicate cycles to this when they can be working on the data application itself. Okay, so how does Rockset work? So I have this little animation slide, so I'll do my best here. So Rockset can ingest data from any source. Here we're showing data streams, data lakes, data warehouses, and operational databases like DynamoDB. And you would typically set up a secure integration with these sources on Rockset. And to find out what sources we support, you can go to rockset.com/docs, and you can see what we have. Now, if there's a data source you want to use, but it's not supported, you can do two things. One, you can suggest a product recommendation for Rockset so it can be put on a roadmap. Or two, we actually have the right API where you can write directly to a Rockset collection. So as you're writing to your database, you can write directly to a Rockset collection. In our workshop today, we're going to actually be using the S3 data connector. And basically what an integration does, it gives Rockset read access to continuously ingest your data in real time. So you'll notice that there's a little like lightning bolt that says like schemaless ingest. This means you don't have to define a schema when you ingest data like you would like relational databases like Postgres or MySQL. So Rockset can automatically ingest structured and semi-structured data like JSON, Avro, Parquet, and so on. And the really cool thing is you can do SQL on top of semi-structured data, and that's typically like not done in some of these databases. And then at RealTime, Rockset infers the schema at RealTime. So once the schemaless ingest happens, Rockset indexes the data via converged index. And so Jack mentioned like there's like a three-way indexing system. This is what we call converged index. So converged index indexes all the fields in all documents that you store in Rockset via a row index, a columnar index, and a search index. The row index refers to storing data in a row orientation, which is fairly standard in databases. It optimizes for row lookups, and this is how like Postgres and MySQL are organized. The next one is columnar index, which is where each column is stored separately. And columnar storage is often used in some databases and in data warehouses like Snowflake and Amazon Redshift. And the key advantages for columnar storage is it has a great potential for data compression because data that looks similar is stored together. And in Rockset, when executing a query on Rockset, it can scan and operate on large batches of columnar data in order to achieve very efficient vectorized processing. And this allows Rockset to have fast queries. And then finally, there's the search index, and that's also known as an inverted index. And you probably have seen search index in search engines like Elasticsearch. It's a really popular and it optimizes for a search index. And on Rockset, particularly, Rockset stores the map between a value and the list of the document IDs that contain that value. So for queries, this means like quick retrievals of a list of document IDs that match a particular predicate. So for example, you can say where something equals something, and then Rockset will optimize for the search index and pull that information out. So Rockset automatically builds on these multiple indexes described above on all data that's ingested, so users get strong performance on different types of queries. And we also have a built-in query optimizer that automatically chooses the optimal index for any given query. So if you're doing an aggregation, if your SQL query is doing an aggregation, it'll optimize for a column restore. If you're doing like a very search-like query, then it's going to optimize for an inverted index and so on. So after you write your queries on Rockset, you can turn them into a data API, also called as a query Lambda. And Jack mentioned this earlier, I think, with command algon. And basically, you can use the Rockset SDK, or you can use the REST API and make an HTTP post request to execute the API, which therefore executes the query. And this allows you to avoid writing SQL in your application. And because Rockset has a data freshness of like 2 seconds or less milliseconds of query performance, you can power real-time applications or data applications like real-time leaderboards, real-time personalization examples, and so on. And Jack covered a couple of data applications that customers are building. And then we're going to actually go through the query lambdas on the workshop as well, so you get to see that in action. Okay, so let's double click into Converge Index, because this is really important for Rockset, and it's actually how we get very fast query performance in milliseconds, is because we automatically index the data that's coming in. So let's see how Converge Index works. In the example below, we have 2 simplified documents that have only one field, which is name. So the documents are document 0 and then document 1. And on the right side, you can see all the key value pairs stored for those 2 documents. So Rockset generates many key value pairs from each document because it automatically stores the data in multiple types of indexes. Okay, so let's talk about the row store. The first key value pairs are from the row index. And you can notice that we use R to denote row store in the key, and use the document ID, which is either 0 or 1 here, followed by the column, which is the name. This approach lets us store all values for a particular document close together, as you would in any row store. And the row index gives us a very low point of lookup latency. The next 2 key value pairs are the columnar index, where the key components are actually flipped. We use C to denote the column store, and then use the column name followed by the document ID 0, 1. And we store all the values for a particular column close together, and this allows us to deliver fast scan times as well as better compression. And finally, on the last one, we have the search index. And you can see, and we actually put the value into the key and store the document ID as a suffix. So we use S to denote the search index, followed by the column name, and then the value. In this case, would be Druba or Igor, and lastly, the document ID, which is 0, 1. So for example, if you're looking for all documents where name equals Druba, you would be able to quickly find all the keys in your key value stores with the prefix s.name.druba. And if you have any questions about Converge Index, feel free to type them into the chat. But this is very interesting because we use row store, columnar store, and an inverted index on all the data. So this is really cool thing about Rockset. So far we've covered what real-time analytics means and the challenges customers are solving. But how does Rockset provide seconds in data latency and milliseconds in query latency to power real-time application. So this is where we're going to actually talk about the architecture and how it works. So Rockset uses the ALT architecture, or stands for Aggregator Leaf Tailor Architecture. And so far we chatted about ingestion and indexing, but each component on the ALT architecture plays a role in this. And so we're going to talk about what they are. And so you'll notice that there's tailor, leaves, and aggregators. And if you look at the diagram, the tailors, that has the right to the leaf nodes, and then on the right side, I guess my right side, you'll see the application makes a post request, and then it goes to the aggregators. The aggregators read from the leaf nodes, and then you read the data coming from the application side. So let's break down what the first kind of node is, which is the tailors. So the tailor pulls new incoming data from a static or streaming source into an indexing engine. The tailor's job is to fetch from all the data sources. So you can see that there's the databases, data streams, data links, and data, and the data streams could be like Kafka or Kinesis or whatever. And then it sends the data to the leaf nodes. The leaf is a powerful indexing engine that uses converge index. So in the last couple slides, we talked about converge index. This is where it happens on the leaf nodes. An index is all data as soon as it arrives from the tailor. And the goal of indexing, again, when you do indexing, is to make your queries pretty fast. The next component is the aggregator, and it's designed to deliver low latency aggregations via column aggregation, joins, relevant sorting, and/or grouping. So the tailor leaf aggregators run as discrete microservice in a disaggregated fashion, such that the tailor, leaves, or aggregator tier can be independently scaled up or down as needed. The system scales tailors when there's more data to ingest. It can scale leaves when the data size grows, and it can scale the aggregators when the number of complexity of queries increases. And this independent scalability allows the system to bring significant resources to bear on complex queries when needed, making it cost-effective to do so because you're scaling your load as the load changes. The other thing that I think it's important to talk about is separation of compute and storage. And this is important because when you have separation of storage and compute, these are some of the things you can handle. One is burst of queries. So data latency is not impacted. You can handle bursty writes, queries are not affected, and you get the best price performance because you don't waste resources. And so if you combine all these things in one machine, for example, and you didn't have separation of compute and storage, you might need to use more CPU or more storage, and you might not use all of it and thus waste money on resources you're not using. And on the compute side, on Rockset separates ingest compute from query compute. So that's the really cool thing about Rockset, is that you do get separation of storage and compute. And even then we have ingest compute versus query compute. So if you're using a data system, I think one of the important things to ask is if it's using the ALT architecture, and if it has separation of storage and compute. And by the way, the ALT architecture is not Rockset owned or branded or anything. It's just a general architecture. And actually, Facebook and LinkedIn use this architecture for real-time analytics as well. So the other thing I kind of wanted to double click into is the tailors, and kind of just do a one-level depth on the technicals of how the tailors, leaves, and aggregators work. So tailors can convert semi-structured data into a format stored on the leaves on RocksDB SST files. And you can see here I have an object. I have some sort of object JSON, and it's writing to the tailors. The data is coming in, and I just wrote that the tailors turn it into a format that Rockset understands. From there, it gets sent to the leaf nodes, and the leaf is where the data is stored. And actually, the way that we store it is on the RocksDB SST files. And we have a RocksDB cloud, which is open source on GitHub, so that's something we can look into. Basically, RocksDB is good for indexing large data sets and serving low latency queries. And then on the aggregator side, it supports full feature SQL execution. So it supports joins, aggregations, sorting, relevance, ranking, and so on. And you can see here that you have your SQL query. It reads the data from the leaf, and then essentially you get a table back, and then you get the results, which is 0, 1, 2, 3 if you were to query object 1. So that's that. And I think this kind of wraps it up for our presentation today. So the thing that we covered is understanding what real-time analytics is and what data applications are. So we broke down real-time analytics in terms of data latency and query latency. And we broke down data application as user-facing analytics and operational analytics. And then we gave examples like personalization and stuff. The other thing that we talked about is what Rockset is. It's a real-time analytical platform that can ingest from any data source. It automatically indexes the data through converged index, which we broke down. And then basically you can serve data to any source within a few seconds. We talked about the ALT architecture and how it's a disaggregated microservice, and basically how each microservice scales as the load changes, which doesn't impact other components. And the last thing that we're going to do, which we're going to get started, is we're going to build a movie recommendation on Rockset. And so that's what we're going to do. And you're going to kind of see it all in action now. So I'll put a pause here and we can go over Q&A. And yeah, let's see. Feel free if you have questions. Now is a good time to ask them. So Philippe says that's quite impressive way of merging index techniques. Yeah, and it's really cool because you get different, you can write different types of queries, and you don't really need to worry about like the types of queries or pre-plan your queries and things like that because Rockset automatically indexes the data 3 different ways through converged index. Do we have any other questions that we want to bring in?
Not from me, not from me for now, but I'm quite impressed for now. Looks really good.
What's like impressive that you see like so far with the architecture or how it works? What's something that you're noticing?
Well, the most important is the querying and using indexes, because this separation between compute and storage is quite a common architecture these days. So this is very, very good stuff to use. But this indexes is something new for me. So
Are you used to like creating and managing your indexes and like pre-planning your queries, or how are you used to basically building your application and using a database to get the results and stuff to understand the data?
yeah, I think only standard as relational indexes and slightly Apache Lucene on Elasticsearch that are basically also similar, but the Lucene is not merging indexes basically, but indexes everything also. So
Yeah, you said you use Elasticsearch.
slightly, yeah.
Yeah, so that's going to be a really good for like text search and things like that, or log search, analytics, things like this.
Yep.
Cool.
Any other questions?
Yeah, feel free to bring him. Don't be shy. It's a quiet crowd today. Doesn't AWS DynamoDB have some speed up acceleration, or was it too expensive? Thomas, can you elaborate more when you say speed up acceleration? I don't think I understand the question. Feel free to unmute yourself too if that's easier.
I think you should be able to unmute yourself if you want.
Okay. Well, while Thomas, if you want to elaborate more, I think that would help me a lot to understand your question. There was an example with some client that used DynamoDB. Okay, let's go back to that. I think that was Command Alcon, if I'm not mistaken. We're gonna go back in history. Oh wait. Okay, I think this is it. Yeah. So Command Alcon used DynamoDB. So what's your question for this slide? When you say speed up acceleration, that's where I'm having trouble understanding. So that I don't know if this is helpful, but DynamoDB has a stream API and has a scan API. Are you referring to like CDC streams or? So I'll come back to this, but let's go ahead and get started on our workshop, which I'm really excited to get started with you. So the first thing we're going to do is we're going to get started on the Rockset.com. Can you guys see my screen here when I go to Rockset.com, or do I need to share another screen?
No, we can see the presentation.
Okay. Oh, okay. So he said there were some queries that were too slow. So for them, I think, Jack, are you still on?
Yeah, I'm still on.
I think for Command Alcon, they wanted to do like complex analytics, right? Like aggregations and things like this, right? For Command Alcon.
Yeah, that's correct, which was difficult to do in DynamoDB. So we gave them more flexibility with the queries they could run.
Yeah, so that was the thing with DynamoDB was aggregations. You can't really do complex aggregations on DynamoDB. So DynamoDB is great for transactional workloads and such, but when paired with Rockset, you can do complex aggregations on it. So what would happen on this diagram that you're seeing here is that Rockset will basically read the data from DynamoDB. You would set the permissions, and then you can run complex aggregations on Rockset and then serve the data to your data applications. And I'm going to show you what this looks like. So I'm going to stop sharing my screen, and I'm going to share a different screen altogether. Let me go back here. A window. Okay, cool. Do you guys see?
Yes, we do.
Okay, cool. So the first thing we're going to do is we're going to go to try free. There's no credit card required. And then you're just going to type in your work email. So I'll just write Nadine plus, what's it, DataOps, right? At rockset.com. And I'll just type in a password. Nadine, Farah, and I'm just going to go ahead and get started for free.
Is there something like academy or university to be able to learn inside the web browser or something like that?
Oh, we'll get to that. We have our community. I actually started doing Rockset office hours, so I'll get into that a little bit more
Right.
after this. So once you see this, it's going to ask you to check your inbox to verify your email. Just go through the flow. So you should check your email, verify it on your email, and then you're going to hit continue, and then you'll see this. So let me I think what's happening is that if I put a new window, it doesn't register. So I need to pick a new window because I just got a new window. All right. So then you'll see something like this, and it's going to ask you to set up your organization. And is everyone okay on this page? I can stop here. If everyone is on this page, I can continue. So I'm just going to put United States because I'm actually based in Seattle. United States. Wait, why is it not? Okay, I think I have to scroll. Where is the? Uh-oh. I think this is funny because when I type in something else, I have like the Google Chrome that automatically popped up. Oh, United States. There we go. And I'm just going to put DataOps. And I'm going to pick Oregon because I am based in Seattle, so I'm closer to the Oregon region. But if you're in Poland, you can just pick Frankfurt. And I'm going to go ahead and create the organization. And it's a 14-day free trial. And if that happens, you can just refresh really quick if there's like a little error, and then you should see this application. And we're just going to build we're going to put explore Rockset, and we're going to do personal hobby, and I'm just going to put programmatically, and then we can just write, I don't know, other. All right, and I'm going to submit it. And so you should get a screen that looks like this. And I'll pause here really quick and see if everyone, I'll give you guys like a minute to check in. I'll give you guys like 2 minutes. Is everyone on this page or do they need more time?
Yeah, that's fine, I think. Also, I must say that the user interface is really beautiful. It's really nice.
Oh, thanks. Yes, we are working really hard on it as well. So I'm just trying to pull up something really quickly, and then we're gonna get started. Let me type in. Okay. Okay, so the first thing we're gonna do is that you're gonna see we have these managed connectors. And if you go to, I'm gonna just pull this up as a resource and I'll send you this page too. If you go to adding data source and stuff, you can see the things that we support. So let me put this in the chat really quick. And where's the chat box? Oh, here we go. This is our doc. So this is something that would be good to use. Okay, I'm going to get out of this window, and then we're going to go to this window. So you see we have MongoDB, DynamoDB. We're actually going to be using S3, or actually go back. We're gonna actually use a sample data set. So under sample data, you're going to see sample data sets, and you're going to click on that. And this is just a sample data set that we have. Basically, it's just a public data set. And so we're going to type in, there are two collections we're going to use. We're going to use movies and movie ratings. The first one is movies. So I'm going to write movies, DataOps, and then I'm just going to go ahead and create the collection. Oh, what's going on? Let's see. Oh, I don't know what's going on. Hold on. Are you guys able to get that going? Rockset. Let me see what's going on.
Live
here.
demo, no worries.
Are you able to get that? I don't know why it's doing that. I also have a lot of accounts, so I'm not sure what's going on. Let me try collections. Create first collection. Sample data sets. It's not part of Rockset. I think it's part of an org. Let me put a pause here really quickly. Jack, are you able to get started on this really quickly? I don't know why I'm getting this error.
I can try. Bear with me.
Or who's Philippe? Are you the one that you were able to get going?
With what actually? Or
sorry?
do we right, so meanwhile, do we have any questions on anything? I think we could do a quick Q&A, I think, meanwhile.
Almost stop. Philippe, you're the one that's talking on it or like going through it. Let me see if you want to share your screen really quick. I think I'm just having a weird error. Let me stop sharing really quick.
Yeah, no worries.
Do you want to go ahead and share your screen? I can walk you through it.
This is to Jack or
Either you, Jack, or Philippe, one of you. I'm just kidding. I think it has something to do with my account. Or actually, let me sign into a different account. Maybe that will work. Hold on. I'm going to sign into a different account.
yeah. Also, so meanwhile, maybe question to Jack: is there any like enterprise version of this?
Sure, that's a good question. So when you first download the trial, you get 2 weeks for free, and you have a certain number of credits that you can use throughout that period. Then after that trial period, you can either use a shared virtual instance size, which is a small amount of compute, and that hardly costs you anything. However, we then have dedicated compute sizes if you want to scale up, and that would be considered the the enterprise version, and that's got all of the security pieces or security functionality that you need in it. So we do it a bit like Snowflake in terms of we do it in t-shirt sizes. So the compute sizes go from small, medium, large, all the way up to 16 XL. And we only really care about storage and compute. So that's what we'd price on. And those dedicated VIs are our enterprise versions.
Yeah, but we are able to use a totally free version with a very small amount of compute. Or this is only 2 weeks, and then there is a very small charges.
Yeah, there's a very small charge after the 2 weeks.
Okay, thank you.
Okay, so the error happened because I have multiple logins, and that's why I was getting it. So we're good now. If you guys pick the sample data set and you go under the movies, you'll see a source preview over here, and that's the data set. Is everyone like kind of on this? So again, if I go to collections and I go to create collections, I just go to sample data set, and then we're going to take movies. So I'm just going to write movies, DataOps. And then I'm going to go ahead and just create the collection. And that's our first collection that we're creating. All right. Everyone is quiet. Who's on this call? Andreas, Archer, Philippe, we were talking, Charslaw, Lucas. Is everyone okay? Everyone on the same page? And then the next thing we're going to do is we're actually going to create another collection. So I'm going to go create collection, and I'm going to go to sample data sets. And now I'm going to type in ratings, DataOps. And then under movies, I'm going to check in the second box, which is movie ratings. And then you can see there's a movie ID, rating, and user ID. So you get the source preview. And then I'm going to go ahead and just create the collection. So those are the two collections that we're going to create.
Sorry, so what is the collection actually?
So the collection is a movie set, a movie data set, and I'm going to show you exactly what it is once it's created. Because we're going to do it.
Yes, but the collection is a schema for data that can be loaded afterwards, or
it's just like it's just data stored in S3. It's like a semi-structured data. So I think it's a JSON object.
Okay, so this is actual data, just without any other.
Yeah, it's actual data. Yeah.
Yeah. Okay.
It's coming from S3. Yeah, it's actual data. So now what can happen is if we go to collections, you're going to see in this upper right hand, there's a query this collection. You're going to type in query this collection. And the first thing that you can do is you can basically describe your collection. So one of the things that when you create a collection, you'll get this, you can just run it and you'll see that there's user ID, rating, movie ID, and then you can see it in a JSON format too. The other thing you can do if you want to see what the schema looks like is you can write describe the collection. In this case, the collection is called this. And I'm going to put a semicolon at the end here. And if I just put my cursor on line 1 over here and I run it, then you can see what the fields are, what the type, and what the occurrence is, and what the total is. And then also, if you scroll down and we're looking at ratings, DataOps, so this one, and we're going to do movie DataOps. So if we look at the ratings, there'll also be the fields that are available here as well, but you can also use describe too. So you can see what these things are looking like. It's still getting updated from the UI side, but yeah, that's how that works. So the first thing we're going to do is we're going to get the average rating by movie ID. And so what this will look like is we're going to write some SQL queries, and effectively we're going to do a join. So I'm going to actually delete all of this and I'm going to start fresh. So if I want to check out actually, let me go ahead. I'm going to keep the comments here, and then I'm actually going to delete this one here. And I'm just going to write describe comments dot movies data ops. And I'm going to put my cursor here and run that as well. And so now these are the two collections we're going to use. And then you can see that the movies collection has these fields, has this type, has the occurrences, and has the total. Now, the one thing I want to note is that on Rockset, each field can have multiple data types, and it's okay. On your SQL query, you're going to have to take that into account, but the ingestion won't fail because you're having multiple data types for a particular field. So for example, if this field might accept int and it might accept string, and that's okay. And actually, if we go back to the collections and we look at movie DataOps, if you hover over the collection, the available fields, it'll tell you the percentage of how much of it's coming on int or if it's coming into another object. So if you look at belong to collection.backdrop path, you'll see that it's string 86%, null 14%. And so those are multiple data types. And so that's the other thing I kind of wanted to show you. But let's go back to the query editor and let's go ahead and start writing our query. So the first thing we're going to do is we're going to get the ratings by movie ID. So we need to select the movie ID, and we want to be able to do aggregation. So we want to average the rating, and then we want to be able to group by the movie ID, and then so on. So one of the things we're going to do is we're going to write select movie ID. Actually, let's just do that from the ratings table. So I'm just going to copy this, and let's just start here. We're going to start building our query. So you can see that there's movie ID, and then these are the rating. But the thing is that these ratings, let's see, it looks like they are, let's look at the movie ID. Let's see. And then, actually, you can actually type in, if you are not sure what the data type is, one of the things you can do is do type of, and then you can type in movie ID. And then you can also see what the data type is. So you can see that it's a string, right? So in this case, we're going to have to convert the string into an int. So typically you can do this when you ingest the data. So we would re-ingest the data and do that. Or you can just convert it on the fly over here. So we can do, we'll have to look at the docs to do that. Let's see. If I want to do convert, you can do, let's see, I'm like blinking out here. I can do select, why am I blinking out here? Let's see. Can do average. Let me look at the query. So one of the things you can do here is you can search. So you can do type. It's like a type. I don't really memorize this, so I have to keep looking it up. Let's see. Oh, cast. That's what it was. That's what it was. So we can do, one of the things we can do is try cast. That's what I was thinking of. So try cast can cast a type as can cast one type as another. So what we can do is we can do average, and we can type in try cast. And then X could be movie ID, and then as int. You can do that. And let's see what this is. Movie ID must appear by the group by clause. So then what we can do here is we can type in group by movie ID. And then what we can do is order by the average TriCast movie ID, because I didn't change it at ingestion time. And then we can just limit it to like 5 values or something like that, or 5 results. And then if I run this, this is what we get. Let me type in this query for you, and I'll send it to the chat box. So you're going to have to change the collection name to the collection you created. In my case, I called it ratings DataOps. So if you named it the same thing, then this query will work. And if you changed it or named it, just make sure you change the from clause. But otherwise, this will work. And so this is an example of doing aggregations on a data set. Now, the thing about this is I actually if I were to do this the right way, when I ingest the data, I could already write this try-cast as at ingestion time. And then that way, all I can do is just average the movie ID without doing this conversion. And the advantage of not doing this conversion at query time is you save on compute. So if you're trying to optimize for compute, these are the stuff that you want to do at ingestion time. Now, TriCast, there's a couple of things. There's also cast and TriCast. TriCast doesn't error out right away. So if the field is not there, I think it produces a null result. Cast automatically fails the query. You're going to have to figure out why it's failing. So it depends how hard of a fast fail you want. But this is an example of writing like an analytical query on Rockset. Now, if we wanted to turn this into an API, we can go do this and we can do, I'm going to get rid of this line here, and I'm just going to put this in another tab. So all I have is line 1 through 6. And then what I'm going to do is save as query lambda. And I'm going to type in rating average. And I'll put DataOps so I know what it is. And I'm going to go ahead and create the query lambda. And then on this, there's going to be a show details. Go ahead and click on the show details. And then you can see that there's a rating average DataOps. And then also you can see that there's a query lambda endpoint. This is where you can do like an HTTP post request. There's also like the curl command and Python. And then also, if you go into the next tab, there's a SQL. You can see what the query is. And then you can also version your queries as well over here. So if I wanted to update this query, I don't know, let's say I want to change the limit to 10 and I wanted to save, I can update the query lambda. And now if I kind of just refresh this page really quickly, now you can see that there's a latest change. There's a timestamp, and you can see that now it's version. You can always reference the previous version, or you can just use the tags for the latest version. Now, if you wanted to execute this on your terminal, what you're going to need to do is create an API key. So on the left nav, there's an API keys. Go ahead and create your first API key. I'll write this for DataOps. And that's fine. I'll just do this as admin for now, create API key. And then I can copy, what I can do is I can go back to the query lambda. And what I can do is I can copy this. I'm actually going to put it in a tab over here. So I'm going to go back to the query editor. And I'm just going to put the API endpoint here. And I'm just going to replace the API key with my API key. So I'm going to go back to the API key over here. Copy it. I'm going to delete this after the session. So I know you guys will see the API key. Don't worry, it will be deleted. And then I'm just going to replace API key over here. And then what I'm going to do is I'm going to copy this and I'm going to share my terminal really quick. So I'm going to open up my terminal. And the reason why I just put in the query editor is just it's really easy to change it. Let me share my terminal really quick. A window. There we go. You guys can see my terminal?
Yes, we do.
So all I'm going to do is I'm going to paste the curl command here. And when I execute it, I get the results back. So this is actually the API. And when we run this curl post request, it executes the API, which therefore executes the query on Rockset, and you get the milliseconds back within, the query latency and things like this. This is a very small data set. This is just to show you kind of how it works end to end. But this is an example of writing analytical, queries and things like this on Rockset. And I think that's it for the presentation. I think this is like the little workshop. I have a lot more queries we can run, but I know we're also close to time, so I'll stop here.